In this video, I'm going to demonstrate how to check your Nikon lens for focus shift. I'll explain why you might want to do this at the end of the video. I have a Nikon Z 50mm f1.8 lens mounted on my Z9. I have my Z9 on a tripod and I have a target in front of the lens near its minimum focusing distance. The first step you want to take is to set up your camera so that your live view shows the effects of settings. That way the aperture changes are reflected in the live view preview. Now I have my camera set up for autofocusing using a single autofocus point. Now I'll go ahead and focus on the target. After you focus, you then want to go ahead and immediately change from autofocus to manual focus. That way we'll get a focus indication on the screen, which is that solid dot. That system uses the same phase detect pixels that the autofocusing system uses, but in this case it uses it to show the indication of whether or not it's in focus rather than driving the autofocus. So now that we're in manual focus mode, I'm going to go ahead and zoom in to maximum magnification, and we can see that the target under the autofocusing point is now in focus. Now watch as I change the aperture without adjusting the focus. Notice at 2.5 that green box is turned red and the solid dot on the bottom left of the screen is turned to an arrow. If I go back to 1.8, you can see how we're in focus now, but then as I stop down, we can see now the subject is no longer in focus. And as I continue to stop down further, it gets further and further out of focus. Now I'll go ahead and zoom in so you can see this. So here we are at maximum magnification, wide open at 1.8, which is where we focused at. So here's f2, 2.2, 2.5, and you can see as I stop down further, the image gets softer and softer. And you can also see that the focusing indication now indicates that the image is out of focus. So if I go back down to f1.8, you can see we're sharp. And then if I stop down to f5.6, it's noticeably softer. The reason for this is spherical aberration, which is an optical phenomenon that occurs on some designs where the focal plane shifts depending on the aperture. So what can happen is if you focus at a large aperture, like in this case at f1.8, but then actually take the photo at a stop-down aperture, for instance at f5.6, that focal plane will shift, so your image will be out of focus and soft rather than sharp when it was first acquired at f1.8. So I'll demonstrate this once again. We'll go ahead and set it back to autofocus. I'll rack the focus to get it out of focus. There I focused. I'll change to manual focus. I'll zoom in at maximum magnification. We can see it's sharp, and we can also see a solid dot indicating the camera believes it's in focus. And I'll start to stop down. You can see right at 2.5, the camera now shows it no longer believes it's in focus. And the image is getting softer and softer as I stop down. Now as I stop down further, our depth of field is increasing, and so it actually gets a little bit sharper than the middling apertures just because the depth of field is hiding some of the effect of that focal plane shift. You can see here the worst as far as the shift is right around 3.5. And then as I stop down further, it's still shifted. It gets a little bit sharper due to the depth of field. So again, here's 1.8. You can see right around 3.2, 3.5, it's pretty soft. And then that shifted plane gets a little bit sharper just because the depth of field increases large enough to hide some of it. Now as for why you might want to do this, Nikon just announced firmware 3.0 for the Z8. And in that new firmware, they have a feature called Maximum Live View Aperture, which allows you to change the camera's behavior in autofocusing. Normally, all the Z cameras focus at the stop-down aperture down to f5.6. The downside of that normal behavior on Z cameras, though, is it reduces the amount of light that goes into the camera. So if you're shooting in low light or in a studio situation where a strobe is providing the light, you're lowering the amount of light the phase detect pixels see, which affects the autofocus performance because the more light those sensors see, the easier it is for the camera to detect contrast. So again, the way Z cameras currently operate is they always stop down to f5.6 so that you focus at that stop-down aperture, avoiding focus shift. The new behavior, which is optional on the Z8 firmware 3.0, allows you to keep the camera at the maximum aperture so it always focuses there, which will improve your low-light autofocusing behavior, but might also introduce this focus shift behavior I've just demonstrated. The reason why I wanted to show you this procedure is every lens will be different. Some optical designs have very little or no focus shift, where obviously this 50mm f1.8 lens has enough of it to make a difference on the resulting photos. It's also going to depend on how far away your subject is. The larger your depth of field, the more some of that focus shift is going to be hidden in the final image, so you're not going to notice it as much. So you'll want to do this test at your minimum focusing distance just to see if your lens basically has a behavior, but then you'll also want to repeat the test at your typical focusing distances, because maybe even with focus shift, it won't matter because it won't show up within the depth of field.